Hi, this is Nasniowski. This class is Discrete Structures, and we're doing the homework problems for section 1.3, some special sets. So these are the homework problems, and I'd like to go through them. Okay, so the book is Discrete Mathematics, 5th edition, Ross and Wright. Now let's go. It says, let's do 1E. Okay. I assume you have the book. I assume you did the problems. I'm going to say this every time at the beginning of every homework problem. Look, if you're just watching me do problems, I know the stuff. You got to do it yourself. So work out the problems yourself and check your answers here. Okay? So list 5 elements. So let's do it. 1E. 1E. List 5 elements from each of the following sets. So how about this? 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5. Okay, those are 5 elements of that. G, n such that n plus 1 is a prime number. So, 1G, let's see, n plus 1 is a prime number. So 2 is a prime number, so 1 plus 1 is 2 is a prime number. 2 plus 1 is 3 is a prime number. 4, 5. So 4 plus 1 is 5 is a prime number. 6, 7. 6 plus 1 is 7 is a prime number. 10 plus 1 is 11 is a prime number. Okay, great. 2C. Let's read this. 2C. List the elements of the following set. Let's write it up. Okay. 1 over n squared, such that n is a member of p, the positive integers, n is even, and n is less than 11. Okay, so they want us to plug in these numbers. N is even, and n is positive, n is even, and n is less than 11. So let's try this. 2. So we'll do this. So 1 over 2 squared, that's 1 over 4. Okay. 4, so that will be 1 over 4 squared, which will be 4 times 4 is 16, 1 over 16. Okay. 1 over 6 squared is 1 over 36. 1 over 8 squared, 8 times 8 is 64, so that's 1 over 64. 1 over 10 squared is 1 over 100. Okay, and that's it. So these are the even. 2, 4, 6, 8, and 10 are the even numbers less than 11. So that takes care of 2C. Okay, so you have these numbers are what they're talking about. Great. 3B. We're up to 3B. Okay, so let's just read it. Well, let's erase. None of these are hard. You just have to concentrate for a second. 3B. So let's do 3B. Okay. List 5. Okay. W. Let's write it out. W. Member of sigma star, where sigma, I guess, is equal to ABC, such that the length of W is less than or equal to 2. Close. Oh, where sigma equals A comma B. Okay, so you want words less than or equal to 2 and AB. Okay, and what do they want? 3. List 5 elements. So how about this? A is a word of length 1. B is a word of length 1. AB is a word of length 1. AA is a word of length 1. sorry, these two are words of length 2, and BA is a word of length 2. Of course, you could write BB, and by the way, the empty word is there too. So that's the answer to that. Okay, next. Number 5, 4D. 4D. Determine the following sets. List their elements if they're not empty, and write empty if they're empty. Okay, so let's do this. So we're up to 4D. 4D. Okay. So we want n member of n such that 3 is less than n, which is less than 7. Okay, so determine the element. Okay, fine. So what do we want? So 3 is less than 4, which is less than 7. 5, 6. So these are the only elements that are in this list. Okay, next, determine number, see, F. 4F. 4F. You ready? X member of R such that x squared, x member of R such that x squared is less than 0. Okay? Now the point is, take any real number, square it, it's more than 0, but it's positive or negative, it's more than 0. And so this is the empty set. Okay, great. 5D says the same thing. You should list the elements if they are not empty and write empty if they're empty. Okay, so let's read 5D. 5D is 3n plus 1 such that n is a member of the natural numbers and n is less than or equal to 6. Okay? So let's do this. So basically, if n is then 3n plus 1 is, okay, so let's do this. So 0, 1, 2, 3, 4, 5, 6. Those are the natural numbers less than 6. So now we have to just take these numbers, multiply them, 3n plus 1. So 3 times 0 plus 1 is 1. 3 times 1 plus 1 is 4. 3 times 2 is 6 plus 1 is 7. 3 times 3 is 9 plus 1 is 10. 3 times 4 is 12 plus 1 is 13. 3 times 5 plus 1 is 3 times 5 plus 1 is 16. 3 times 6 plus 1 is 19. Okay, that takes care of that. So that's 5D. Okay, great. Let's do the next one. By the way, if I get any of these wrong, put a comment in the video, and maybe you'll get a prize. Okay, great. This is 5E. We're up to 5E. Ready? This is n member of P such that n is prime and n is less than or equal to 15. It gives us a little hint of 1 isn't prime. Okay, so they want all the prime numbers, positive numbers that are prime and less than 15. So how about this? 2 is prime. What do they want? Everything? They want all the elements. So 2 is prime, 3 is prime, 5 is prime, 7 is prime, 8 is not, 9 is not, 10 is not, 11 is prime, 13 is prime, 14 is not, 15 is not. That's it. So those are the elements. Great. Let's do 6C. We're up to here. 6C. do this. N member of n, let's write it out, n member of n, such that n over 3, the floor of that is equal to 8. Okay, so let's see. What number, when you divide it by 3, is equal to 8? Well, 3 times 8 is 8, 16, 24. So 24 divided by 3 is going to be 8. So 24, but it's the floor of that. So what about 25? 25 divided by 3 is going to be 8 point something something. So 25 also. The something something, the floor chops out. 26 divided by 3 is also 8 point something something. So 26. Okay, what's 27 divided by 3? That's 9. So we gotta stop. So this is your answers to your question. Okay, great. Let's do 7a. Again, nothing here is hard, but it's good to see. Okay, we did this, the last thing we did was because of this thing, with this notation. So 7a, this is a is equal to the set of n member of n such that n is less than or equal to 20. 20. Okay, so all the numbers 0, 1, 2, 3, 4, 5, 6, 7, all the way till 20. So there's 21 elements in there. Okay, great. So A says list off the elements n member of A such that 4 divides into n. Okay, n member of A such that 4 divides into n. So what goes into these numbers? So let's go through it. 4 goes into 4. 4 goes into 8. 4 goes into 12. 4 goes into 16. And 4 goes into 20. And that's it. Okay. Let's do 7b. Okay, we get to do A and B. Let's do 7b. N member of A such that n goes into 4. So this is n member of A such that n goes into 4. What divides into 4? Well, this is zeros. Does 0 go into 4? I don't know. It depends on your definition of dividing into. I don't want to put 0, but 1, 2, and 4 go into 4. So that takes care of that. Okay, great. Next, 8, C, and D. How many elements are there in the following set? So let's do this. N member of Z, 5 is less than n, which is less than 73. So this is 8C. So we're given a set, and you want to know how many elements are in that set. So n member of Z, such that 5 is less than n, absolute value, that's absolute value, less than or equal to 73. Okay? So, how do we do this? The idea is as follows. How many elements are from 5 to 73? So, the simple answer is 73 minus 5. Okay, 73 minus 5, but there's one more. Okay, so let's do that. 73 minus 5 will be all the numbers from 5, not including 5, till 73. So take 73, subtract 5 is 68. Okay, 68, but plus 1, because we want to include 5. So it's 69. 69, again, 73 minus 5 is 68, plus 1, because we want to include that. But those are just positive numbers. What about negative numbers? These could be negative. N member of Z, so these can be numbers. So the answer is 69 positive numbers and 69 negative numbers. 9 plus 9 is 18. And so this is 138. So there are 138 elements there. I think I'm right. Let's do D. Okay, D is 8D is n member of the natural numbers. Oops. D, n member of the positive numbers, I'm sorry, n number of z, 8d, such that 5 is less than n, which is such that 5 is less than n, which is less than 73. Okay, so how many numbers from 5 to 73? So that's one less, because we're not including 5, so it's 73 minus 5, take off the 5, that's 68. But you also don't have 73, so you have one less than that, so that's 67. Okay, so there are 67 elements there. Okay, great. Let's go. We're almost finished. We have 3 more sets of problems. Again, I didn't check the answers in the back of the book. I'm sure I made 1 or 2 mistakes. If you think I got wrong, check the comments. If someone finds a mistake, then I will either say yes or no, etc. Okay, you ready? Repeat exercise 8 for the following sets. How many elements in the following set? Write infinite if the set is infinite. Okay, 9a. Okay, from A to D. So let's do it. X member of the real numbers such that 0.99 is less than x, which is less than 1.00. Okay, so basically we're looking for this interval, 0.99 comma 1.00. Okay, and the answer is how many elements are there? There are an infinite number of elements. Okay, this is the real number line. So between any 2 points, there's an infinite number of points. No matter how close they look, there's an infinite number of points. Okay, great. Next, B, the power set of the set containing 0, 1, 2, and 3. Okay, anyways, this has 1, 2, 3, 4 elements, and so that's 2 to the 4. There are how many elements here? There are 2 to the 4 elements, which is 2 times 2 is 4 times 2 is 8, 16 elements. 9c. 16 elements. 9c. The power set of n. Okay, well, it's going to turn out all these subsets, all possible subsets of natural numbers in infinity. We're going to see this later on in section 13.3. We're going to talk about different levels of infinity. So this has a very high level of infinity. Next, but we don't need that. Okay, n, let's do d, 9d. This is n member of n such that n is even. Okay, anyways, there's an infinite number of even numbers. So we'll leave that alone. Okay, so that finishes 9. Okay, great. 12a. Consider the sets. Okay, so let's do this. Okay, so let's do this. Let's go through this. 0, 1. That's a set of elements. This is 0, 1. And this is 0, 1. Okay, now these are 3 different sets. Let's go through what each one is. 0, 1 with curly brackets, that's a set that contains 2 elements. The number 0, the number 1. This is all the real numbers from 0 till 1, not including 0, not including 1. And this is all real numbers from 0 till 1, including 0 and including 1. Okay, great. Now we have to answer questions. Number 12. Question. 0, comma 1. Question, is that a subset of 0, comma 1? Okay, and the answer is, let's go through this. This set contains 2 elements. This set contains an infinite number of elements. But this is all the numbers from 0, not including 0. This is all the numbers till 1, not including 1. Anyways, this has 0 and 1, so this is not true. So we write false. Okay, that's 12a. 12b is 0, comma 1. Okay, and here these are 2 numbers, 0 and 1, and this does contain 0 and it does contain 1. You like to think of these as integers. Well, the integers are in the real numbers, so this is true. In other words, here's 0, here's 1, it is true. Next question, is 0, comma 1 a subset of 0, comma 1? This is 12c, and the answer is true. Okay. This contains all the numbers from 0 till 1, not including 1. This contains from 0 to all the real numbers from 0 till 1, including 0 and including 1. So basically, this is the same set as this, but this contains 2 more numbers, 0 and 1. Okay. 12e. I'm sorry, this A, B, C, D. Okay. Next is this 0, comma 1 is a subset of Z, and the answer is yes, it is. Z has all positive and negative numbers, including 0. Here's 0, here's 1. So yes, it is true. Okay. And final, I'm sorry. Let's do E. Zero, comma 1. Question, is that a subset of Z? And the answer, no, that's false. This contains all numbers between 0 and 1 too, like 0.386427, whatever. But this only contains whole numbers, so this is absolutely false. In contrast, let's do F. 0, comma 1, subset of Q, and the answer is this is also false. This is all real numbers, whether they're fractions or not. So there are irrational numbers between 0 and 1 here, and this only contains rational numbers. So no, this is not a subset of that. Okay. That takes care of that. Next. A. Okay, let's do this. They give you 3 alphabets. Sigma 1 is equal to A, B, C. Sigma 2 is equal to A, B, and CA. That is a symbol. That is a symbol. So that's one symbol. So it might look like 2 symbols, but it's one symbol. And sigma 3, which is equal to A, B, and capital A, little b. Determine to which of the sigma 1 star, sigma 2 star, sigma 3 star each of the words below belong, and give its length as a member. Okay, A, B, A. So let's do this. A, B, A. It could be here, and it could be here. Okay, it could be here. Let's read this again. Consider the following. Determine to which of the sigma it belongs to. Okay, and by the way, it could be here too. So all 3. And to all 3 of them, the length is 3. Okay, so that was an easy, that was a giveaway. problem. Now, this one. Ready? B, capital A, B. Again, that's one symbol. The only thing here that has that capital A, B is this one. So this is a member of sigma 3 star. Okay? And the length of B, A, B as B, A, B is equal to 2. One symbol, two symbols. Okay, and finally C is CBA, CBA. Well, C shows up here, but only as the beginning of CA, and so this is a member of this. It's not in here because there's no C here, so this is here, CBA. So this is equal to 3 elements, and CBA is a member of sigma 1 star. So it only comes from there. Okay. Anyways, again, there was no hard questions here, and there was a ton of topics that we covered. Just wanted to hit every one of them and talk about it. Okay. Thank you. Have a great day.